something like this, 4x squared plus 2x plus 1. And I say to myself, how many terms are there in there? Well, there's actually 3. You might look here and you see, well, there's 4, and then I know 4 in front of the x squared is 4 times x squared, but this is all one term. And the way to identify exactly what a term is, it's everything that's tied together by multiplication, right? The borders between terms, the thing that makes it so that this is a different term from this one here, is that they're separated by a plus sign. Right? And we'll see this gets really important when you're distributing later with brackets, okay? Because the plus sign tells you how many times you got to distribute into an expression. So here I've got one term, here I've got another term. The 2 and the x are glued together by multiplication. That means they're one term together. And then I have just the 1, which is a constant term. So here in terms of number of terms, let me write in here, my number of terms here is going to be 3. Pretty small little 3 here. The coefficients, I got a bunch of coefficients here, right? Remember, the coefficient is just the number in front of the variable in a term. So if I look at this term here, the 4x squared, the coefficient, I'm sure you're yelling it at your screen right now, is 4. And I also have, put a little comma in there, I also have a coefficient in front of this term, right? This term is 2x. I got a variable of an x here, and the coefficient is that number 2. So the coefficients that I have here, there's 4 and 2. Now, if I look for constant terms here, remember, a constant term is just a plain old number. I see that I've got the number 1 here. There is a constant term, and it's the number 1. And lastly, what are the variables going on? Well, I see an x squared here. That's just x is the variable. X is the variable here. There's only one variable to worry about in this example. It's the letter x. Now here I have 5ab squared minus 3ab. How many terms is that? Again, I say to myself, whatever is tied together by multiplication, like this means 5 times a times b times b. That's what the squared means. There's 2 b's there. This is all one term. It's all glued together with multiplication. Here I have 3, well actually minus 3 times a times b. That's all one term. And since I've got this minus here, remember a minus is just like a plus negative 3 here. This is what divides these into 2 different terms. So I've got 2 terms in this expression. As for what the coefficients are, this is a little trickier than the last one. I'm sure you can see that the coefficient of the first term here is just 5. So that's not controversial at all. But the coefficient of the second term, remember that the negative always sticks with the term here. So the coefficient isn't just 3, it's actually negative 3 for that one. Make sure you have the negative included in the coefficient. As for the constant terms here, there is no constant term. Remember, a constant term is just a plain old number. So there is no constant term here. And in terms of the variables that you're using, this is pretty easy, right? I'm using a, and I'm also using b in these terms. I've got a, b here. I'm also using a and b as well here. All right, for this one, number of terms, I got x cubed y as a term. I've got minus 10xy as a term. Minus y as a term. And 4 is also a term. Even though there's no letters, no variables, it doesn't feel very algebraic, it's still a term. And that means that in total, I've got 4 terms in this expression. What are my coefficients? Well, this one doesn't look like it has a coefficient, but if you're following closely, you'll know there is actually a coefficient here. Even though we don't write it, the number 1 is the coefficient for that first term. So let's include that one. That the number 1 is a coefficient. In front of here, you might say, well, the coefficient here is 10, right? I got 10xy. Wrong, right? I'm sure you remember back here we said the coefficient was minus 3. Here the coefficient is minus 10. The minus is part of the action. It's part of that term. It travels with it. And if you're thinking along those lines here, you might see it and say, okay, I don't see any number here. Not really sure what to do. Then you remember, when there's a number, there's actually a number 1. And because there's a minus, it's actually a minus 1 as the coefficient for this term. And then here, this isn't a coefficient because it's not in front of a variable. Instead, if I have just a plain old number all on its own, that would go in this column because I've got a constant term. Lastly, if I want to list off the variables that I'm using here, I'm using an x, I'm also using a y. Those are the variables in play. Now, a little bit further down the page that you're looking at, you'll see this box that needs filling in. And this is just so you know the different types of algebraic expressions. An algebraic term on its own can be an algebraic expression. If you have an algebraic expression that's only got one term, then you call it a monomial. Like mono, you guys know that, I'm sure, from the game Monopoly that everybody plays once in a while and never finishes, right? Monopoly actually means mono, which is one, and poly, which means many. It's one person owning a lot of stuff. Like if you get all the green properties, it's a monopoly because one person has all of them. Mono has poly. Anyway, mono means one. Monomial is only one term. So if I come up with an example of what a monomial could be, I'd say, well, 3x would be a monomial. Or I could also say something like 12x squared y. Or let's just do 12xy. Or even this could also be a monomial, right? If I just have the number 4, that's a constant term, but this still counts as an algebraic expression, right? It's getting a little bit abstract. But whenever you have exactly one term, that counts as a monomial. Binomial just means two terms. So instead of having one term on its own, I could have something like this. X plus y would be a term. Would be a binomial. Or I could have something like this. X plus 2. That's also a binomial. Right? These are two examples of binomials. Trinomial, you can probably guess what that looks like. That's just three different terms, all together in the same algebraic expression, like x plus y plus 3. Now, you see here, this little thing here, what this is saying is that whenever you're talking about a binomial or a trinomial, those are examples of polynomials. Okay, I'm going to write that word here so that you have it down. A polynomial is just any algebraic expression where you have more than one term. A binomial is an example of that because it's got 2. 2 we all know is more than 1. Trinomial's got 3. 3 is more than 1. You could have 4 terms, and it would be a polynomial. You could have 5 terms, it would be a polynomial. Right? And those ones do have special names like binomial and trinomial. It's just nobody really uses them. Right? Like an example of a polynomial that has 4 terms, you'd call that a quadrinomial. You don't need to know that. Don't worry about it. You won't be tested on it. But in case you're curious, they all do have funny names. Moving a little bit further down the page, there's a couple of principles that I want to make sure that you have in your vocabulary because they actually make a lot of what we do in algebra possible. Without these, we wouldn't be able to do a lot of the operations we need to do. And here you see a plus b is equal to b plus a. If I'm adding things, then the order that I add them in, left to right, isn't going to change what the final answer is, right? If you think of an example like 3 plus 4, does that give me the same thing as 4 plus 3? Well, it does. Now, that's going to be important. Likewise, I can rearrange the order of things that I'm multiplying. It won't change my answer. This principle, you'll see that it'll be important for what we can do. This is, let me make sure I spell this right, commutativity, the principle of commutativity, the property of commutativity. That you can change the order when you add things and you'll get the same thing. You can change the order when you multiply it. It won't change what you have. This one here, you see I've got brackets around a and b. It's saying if I add a and b first and then tack c onto that, and if I add b and c first and tack a onto that, I'm going to get the same thing, right? I got an equal sign here telling me that it's the same thing. For multiplication, likewise. If I multiply these two first and then multiply that by c, I should get the same thing as if I multiply the second and the third one and then multiply that by a. This property is the property of associativity. What these names are is not that important in terms of knowing the names, but it's important to understand these are hard mathematical principles, and without them, we would be stuck. The idea that whenever you add 0 to something, you don't change it, that is